All right, number 6 is a 45, 45, 90. We want to find these missing sides, x and y. Because it's a 45, 45, 90, I know that x is congruent to y. And also that it has side ratios of 1 to 1 to root 2. So if I take one of the legs and multiply it by root 2, I'll get the hypotenuse. So let's go ahead and write that. Take one of the legs, multiply it by root 2, and I get the hypotenuse, but we have an expression for the hypotenuse. So it's 2 root 6, and there's my equation that I can go through and solve for x. So I want to solve for x. I want to get rid of whatever is being done to x. So I divide by root 2 to get that to cancel. Whatever I do to one side, make sure we do to the other. X equals 2 root 6 divided by root 2. Now, thing we got to recognize here, number one, is that we have a square root in the denominator and we can't have that. We want to make sure that this is rationalized. Or in other words, we want to make sure we get the square root out of the denominator. Before I start multiplying by stuff, recognize that in the numerator we have a root 6, and I can rewrite root 6 as root 3 times root 2 using those radical properties. So let's go ahead and do that. 2 times root 3 times root 6, or root 2, sorry, over root 2. And that's nice because it allows us to cancel our root 2's and we don't actually have to rationalize because our square root gets canceled out anyways. So simplify and I end up with 2 times square root of 3 for my x. Nice thing is a 45, 45, 90. So whatever x is, y is also. So y is that same exact value, and we're done.